Okay, this will just be a quick recap of the examples from class on Friday. Our first example, we have secant squared x minus 1 over sine squared x. We want to write this in terms of sine and cosine if we can, and I think I see a path. Since I have a squared term, I know I'm going to be using a Pythagorean identity. All right. I have subtraction in there, so I know it's not going to be one of these primaries that we've got down here listed, but it's going to be a modification, one of those. And I'm going to look at the one that has secant squared in it. It's this one right here. How could I rewrite that with a subtraction in there? Well, just subtract 1 from both sides, and I get tangent squared of x. Does everybody see that? Subtract 1, and I get tangent squared x equals secant squared x minus 1. And that's what's in our expression up here. So we're changing that to tangent squared of x. Hopefully you'll see where that's headed. Over sine squared x, no change. We're already in terms of sine. I'm going to rewrite tangent, though, one more time as sine squared x over cosine squared x, leaving my denominator alone, sine squared x. Now we will keep change flip, multiply by the reciprocal. So we have sine squared x over cosine squared x times 1 over sine squared x. And I hope you can see that these will cancel, leaving us with, let's see, 1 over cosine squared x. Not to leave that in the form of a fraction, we'll rewrite it as its reciprocal, secant squared x. And again, if you want to put secant squared x and secant squared x minus 1 over sine squared x in your graphing calculator, you'll see that they produce the same graph, and thus you can verify that you've done your simplification correctly. Moving on. That was problem 1 from the homework, by the way. I believe this is problem number 4. These were the examples I did in class. We have tangent squared x minus tangent squared x times sine squared x. And we can factor out a GCF in this case. There's a GCF of tangent squared x. Tangent squared x. So let's rewrite this. Tangent squared x times, well, tangent squared x over tangent squared x is 1. And a little cancellation over there, so minus sine squared x. All right. Each of these can be rewritten using one of our identities as something in terms of sine and cosine. Right here we have tangent x equals sine over cosine, so tangent squared x becomes sine squared x over cosine squared x. We'll multiply that by, now let's see, if we take this identity, the first of the Pythagorean identities, and we simply subtract sine squared x from both sides, we have cosine squared x equals 1 minus sine squared x, which is what we have in our problem. So we can substitute cosine squared x. I'll write it as a fraction just to make it look nice. Cancel off the cosine squared of x, and we're left with sine squared x over 1, but it's just sine squared x. All right. Last example. We have cosine x plus tangent x times sine x. Well, let's see what happens if we rewrite tangent x in terms of cosine and sine. So we have cosine x plus sine x over cosine x times sine x over 1. Well, that didn't work as planned, did it? We thought maybe the sine would cancel off, but no. So in this case, we've got a little bit more work to do. What's going to happen if we multiply sine x times sine x, we're going to get sine squared x, and we'll have a numerator of cosine x. We'd like to be able to combine these two terms, so we want to get a common denominator. All right, and the common denominator in this case is just going to be cosine x, the denominator over here on the side where we have a fraction. In order to get that, we're going to multiply this side by cosine of x over cosine of x. Think of that as a fraction, right? So we get cosine squared x, that's interesting, over cosine x, there's our common denominator, plus sine squared x over cosine x. Adding the fractions together, now that we have a common denominator, we get cosine squared x plus sine squared x over cosine x. And hopefully you can see, based on our first Pythagorean identity, that our numerator is nothing more than 1 and our denominator is cosine of x. Again, we don't like the fraction, so we'll rewrite that as the reciprocal secant x. And again, you can prove this using your graphing calculator.